We're going to probably plan about going for 45 minutes. And then one of the reasons for having this panel was in the next discussion sessions, we're going to have a discussion session on the same topic. So we wanted to kind of anchor that discussion session starting with this panel. So those of you who go to that discussion session have kind of concrete things to start off with. So I know we all have thoughts and opinions on topics. Sort of for me, you know, the issue of ethics of doing data science, the people it affects, the bias in our systems, how to understand it, how to mitigate it. There are lots of the really critical issues because, again, as we've talked about, this work is about people, right? We're trying to improve people's lives, and if the ethics and the bias and all those issues are extremely critical because we're affecting people's lives, much more so than they are in the corporate world, right? If we give somebody the wrong ad, who cares? In some cases, it does matter. But in the effect of not giving somebody a public health intervention are much, much, much worse than showing them, you know, one ad of the millions they see. So I think that, I'm not going to argue about the pros and cons of it, but I think the impact we're having on people really means that we have to be very, very, very cautious about doing this work. At the same time, we want to make sure that it doesn't stop us. You know, is it better than what we're doing today? Could it improve things? So we want to be able to have a discussion. I don't think there are things that we can say definitively about this topic. I don't think we're going to reach a conclusion or we're going to reach that and find answers, but I think this is really more of a discussion topic. So what I want to do is really use this panel to kind of highlight the current work that's happening in this area and raise certain issues that we can have a conversation about that continues in the discussion group, but then continues afterwards, because I think the larger community needs to sort of have more concrete opinions on that. So with that, I want to sort of start with having the panelists introduce themselves, and then we'll start with some questions. So Julia, if you want to start.
Is this on? Yeah. Okay. And it has to be exactly 3 inches from my face when I speak. So my name is Julia Stoyanovich. I am an assistant professor of computer science at Drexel University in Philly. And my background is in computer science and specifically in data management, databases. So this is a traditional, solid computer science field, right? But of course, the overlap and the influence that data management has on data science and data science has on data management is unquestionable. And in the last 2 to 3 years, I've been really just very, very interested, and I have been devoting almost all of my time to the question of how can you operationalize, embed in data processing, data management, data analysis systems, these questions about what is fair, what is ethical, what does transparency and interpretability mean, right? So how can we put a precise meaning to these terms, given that people have been arguing about what is fair for thousands of years, right? And so how can we tangibly work on this? It's very risky, and yet we must work on this. We must provide tools that will enable companies and public agencies alike to behave responsibly.
Hello, my name is Mattie Sriram. I'm a professor of computer science at the University of Chicago and TTIC. And I've been most of my professional career working on machine learning and making prediction better. And in the past 2 years or so, started thinking also of issues of non-discrimination in learning, which to me, even just the name, the first lecture of course in machine learning, you learn about linear discrimination. Everything we do in learning is discrimination. And so I've been trying to think of what does it mean to have non-discriminatory predictors, and for me it's very different because it's now thinking of how to make predictors in a sense worse. And I think that's a real thing, because from my perspective, there's always sort of a fundamental thing is a contrast between having better predictive accuracy and not discriminating based on things that you want to not discriminate for whatever social, moral, legal reasons. So those are the topics I've been thinking of lately, and also talking with some companies how to inject non-discrimination or ensure non-discrimination in various statistical prediction systems, I should say, but mostly focusing actually exactly the cases where rates that are not important, like ad placement and resume screenings and things like that, and search results, what you get when you search for images, which images you get. All these things are things where every single instance is not so important, I agree, but the aggregate effect can be very strong and be very problematic when we have various biases there.
My name is Lisa Green, and I'm at Domino Data Lab. It's a for-profit company, and I head up the social impact work at Domino Data Lab. It's called Domino for Good. Previous to Domino, I've spent a long time thinking about the balance between open systems and transparency and privacy and digital rights. This is an area that's held my interest for several years.
So one of the things before we start the panel, in my mind, the mix of a panel on this topic has to kind of include three types of people, right? People who are building these systems, people who are acting on these systems, and then the people who are being acted on. And so if you notice, sort of the first two people here are kind of people who are building these systems. So what I want, and then the people who are acting, so think of sort of Lisa as the person who will be helping people act on that. The role I want all of you guys to play is people who are being acted on. Because you should have as much, if not more, I would say more of a say in what happens. If you want your data to be used to help you, you should have a say in that, and vice versa. So think about yourselves right now, put in a position of how is it like being acted on, and kind of question when we sort of go into the Q&A, and question these people as, with that role, because we don't have that role, there's no person here sitting that, because I wanted you guys to sort of play that role. So with that, I think, as sort of Julia, you're sort of who's building a system like this, what do you think of your responsibility as a developer of a system, and what are the values you want to encode? Should you encode any values into the system? How do you think about that in your work?
Yeah, so this is a great question, right? And I think it's very important for us, for researchers and as researchers and as developers, to understand that we are not the judge of what is right and what is wrong, right? The society is the judge of that. And for us to build systems that are useful and relevant and that can help society become better, right? Not worse. We have to enable people, relevant stakeholders, to specify the kinds of objectives that they want the system to encode. So for me as a developer, it is not my role to decide that out of the many, let's say, fairness measures that have been defined, my favorite is this particular kind of statistical parity, and therefore this is going to be the system that the measure rather that my database encodes forever. No. Instead, what we need to think about is what are some reasonable use cases, and how can we provide a generic sort of a platform that would allow the relevant stakeholders to understand what is going on and to customize the system, to control what the system does in such a way that the stakeholder, a policymaker, a developer, a user, is able to, in an informed way, assume responsibility for their actions. Right? So this is one of the big problems with these algorithmic decision-making systems, is that it's not clear whose responsibility it is that the system is racist suddenly. And I feel that this is our primary goal as developers, as researchers, as users, as data scientists, is to think about responsibility being communal, being distributed, and building systems that support that.
Yeah, so that's a good point. So you're asking a policymaker to decide what trade-off do you want. So Nadia, if I was a policymaker, which hopefully never will be, and I came to that, well, I want a system that's perfect. It gives me, I don't want a trade-off. I want something that accurately identifies people who might be at risk, shows me how to intervene, and is not biased at all. How do you build a system like this? If you, and can you build a system like this?
Fries with that.
It's important to understand what kind of biases, and I think that this is where I don't completely agree that the pipeline should be that we listen to the policymakers, hear from the policymakers what the policy should be, and go ahead and implement it, because I hope there probably are many policymakers here, but policy. So in discussion, I think that people that work on data analysis, on statistics, on machine learning, there are many things I think that we can bring in and we can understand. We can help by that help the policymakers do it much better. The thing I'm not going to say is that policymakers don't always have the best quantitative understanding.
Right.
Well, and there are many, some I'm sure do, but. And so I think that it's, when I talk, and this comes up when I talk about non-discrimination to computer science audiences, and most of them, I present some definition and say, well, is this what the law requires? Is this definition the law? Why don't you just take the law? Say, well, I know, the law does not, there's no mention of conditional probabilities, and definitely not in legislated law, and also not really in precedent law. And so if you want the definition, it boils down to, what should be conditionally independent of what, and what, that you're not going to find in the law. And so I do think we should be bringing in, so you started the question of the policy, I think we should be talking to policymakers about what kind of biases, what biases mean in some senses. So going back to your question, I really think that when we talk about having perfect prediction, so one thing you should first of all ask yourself is, suppose I gave you the exact perfect prediction. I could actually predict, with 100% accuracy. Would you be fine with using, if you could actually know the future, would your policy be okay with using that? Because sometimes, you might have good reason to not use those predictions, actually deviate from that to achieve various, longer-term social goals. And then, in that case, no matter what I do on my side, nothing's going to help you. I can give you perfect.
That's right.
So if you are happy with perfect predictions, then now, if I can deliver you perfect predictions, then we're all happy. If I cannot deliver you perfect predictions, if all I can do is make some statistical prediction, then now I think the first question to ask is it at all reasonable and fair to use a statistical prediction, regardless of any discrimination or non-discrimination, right? So if I'm using my statistical prediction in order to decide which ads to show you, then you're probably fine with that, because if I showed you random ads, you'll be fine with that. If you look at the newspaper, you get random ads. Everybody's fine with that. Nobody's complaining. Well, maybe complaining their ads, but it seems that it's not unfair, right? But in other situations, that if I used some statistical prediction that was correlated with reality but had lots of errors, if I used that for extreme life-affecting decisions, definitely things like criminal justice, but even things like decision on loans, I think that regardless of non-discrimination, that might be that can be viewed as problematic, because again, I'm only making some decision that I cannot justify except based on its correlation in the data I have. Right. And so, in such a situation, we have to understand: are we interested in the best accuracy that we want, or are we willing to sacrifice accuracy in order to intentionally not get the best accuracy because we're afraid that the errors that I'm injecting are actually either disproportionately affecting a protected group or injecting all kinds of other biases that we do not want. And this is where these trade-offs comes in, that maybe I could make an excellent, maybe I can improve my prediction by taking into account gender or race. And I think that the classic example of that is racial profiling for maybe in security situations. And I think it's an open question: is that fair or not? Is racial profiling in security checkpoints it does increase statistical predictive power at a cost, at a social cost, and that's basically I think the core question of is the situation such that we really want the maximum accuracy, or do we want to compromise on accuracy in order to, for example, not do things like racial profiling?
Right. And one of the things you're sort of mentioning is, what is it that you want out of the system, right? So if I'm using, one of the things that comes up in our work quite a bit is, we're basically, take criminal justice, right? If we think there is a person who might be at risk of going to jail, we want to figure out as accurate as possible who these people are going to be if our goal is intervening them, redirecting them to give them other types of care that may prevent them from going there. So it's not if your goal is to make sure that person doesn't end up there, you want to be as discriminatory as possible. You want to use every single thing you can about this person because the other side will be using it, right? This is an adversarial situation where, let's say the criminal justice system is biased. They're going to use those attributes implicitly or explicitly, and you might end up somewhere. And if we can identify you're going to end up there, we can prevent you from getting there. In that case, you might be okay with discrimination. So, kind of moving to Lisa, how do you think about, what are the requirements of, if you were going to act on these systems, you were going to sort of do something with them, what would you want from these systems to provide you? What levers, what controls, where you can say, here are the actions I'd like to take. Help me take those actions intelligently, ethically, and fairly.
Well, I think the first thing is, so transparency is a difficult word. It means a lot of things to a lot of people, but I think the first thing is transparency and understanding the factors that go into it, understanding the weighting. And if you don't speak math, then it can be explained in a simplified way. And then I think you have to bring the public into it. You talk to the people it acts upon. This can't be a decision that's just made unilaterally by large corporations, or even sometimes like by academia. You make a decision and you're like, this is the best system, and then it's rolled out to public or private sectors, the government, criminal system. There has to be a consensus. There has to be visibility into it and a vote, exactly, but a voice for
how voting works here.
Yeah. Yeah, I guess that's what I would say. And we had that session yesterday. There's a great session about human-centric design and data science, in which we talked about how would you improve the system of credit reporting. And many, many groups hit on no one understands this black box, and that's not okay.
Right. So basically you're talking about, a system, right? So Julia, what does that system look like? What are the components you would want? Is that a machine learning system? Is that a data system? Is it not a tech system at all? It's a larger thing where machine learning and data and everything is a small part of it. How do you sort of think of a system like that?
Yes, so great question. Thank you. So first of all, I would say that it is a system that involves people and technology and data, right? So the system and the problems that we're looking at here are not in any way purely technical. They are very much socio-technical, and this was already stressed by several people at this conference, but I just want to say this again, that what we're doing here is we are taking data about individuals, we're making decisions that are very important or may seem unimportant, but actually are important still, and we are, by deploying this ecosystem, changing society, right? So it's something that is changing the way that people live and interact. But maybe now to zoom in on the technical components of the system more. So we all participate in the data-driven ecosystem, right? Somebody shares data. It could be individuals, it could be organizations. So let's, for example, take a case where we need to decide jointly about what are the most effective interventions for the homeless population. What kind of an intervention should each individual receive, and how do we optimize the allocation of resources that the overall system has, just to make this a little bit more concrete, right? So what does a system of homelessness intervention, a data-driven system, look like? There are individuals and there are agencies on the ground that are sharing data, and their data production and sharing environments are heterogeneous, right? So nonetheless, there may be a need to bring all of this data together, to clean the data, to integrate it, to be able to look at it in a kind of a combined joint view, right? So there are multiple steps in this process already that I mentioned. Data sharing is one, reporting is one, sharing is the next, cleaning, integration. After that, there's going to be some sort of a filtering step, right, where I'm not going to look at my entire homeless population, but perhaps I wanted to focus on a particular population that has been underserved, like the young adults or the minors. And then the result of that, I'm going to put in, feed as input to a data analytic engine. And then I'm looking at the results, I'm interpreting the results as a policymaker or somebody who dispenses services, and I have to look back, and I have to understand, was there a mistake somewhere? Is there some bias that I'm tracking that I need to mitigate? Is there data missing? Should I be asking agencies on the ground for more data about a particular subpopulation? Because I see that lack of this data is actually making it so that my predictions for this subpopulation are inaccurate. So it's a very complex ecosystem of which this predictive analytic engine is a very important part, but I would argue that it's a part that has been perhaps overemphasized in the technical development and the research community, and that we need to really, to be effective, we need to look more closely about how the data gets there that the classifier, say, is processing. Did the data fall off the back of a truck? Do I know something about it? Do I know something about its quality, coverage, how representative it is, things of that nature?
One of the things you mentioned is, so in your loop, you're going all the way from collecting the data, looking at its coverage and bias in there, and then you go through the process, and then you said, well, then the policymaker interprets the results.
Right.
That's, and Nadia and there's breadth have a policymakers don't really know how to do that. So how, I guess maybe Nadia, how do you make those results interpretable? What does that mean? What does interpretability mean? And then how do you, if that is a part of the system, how do you make those results interpretable to a policymaker who's never going to be a machine learning or a data science expert? Maybe 5 years from now, but today they're not. How do you do that?
This goes quite a bit outside of my sort of expertise and how I think of things after a bit, because making sense of data, looking at data mining and data visualization is, I think, a very complicated and interesting question. That it's not, but it's sort of very. I have to say that it's not.
Let me ask a different thing. So you're working, you're working on the machine learning side, and you're building models and classifiers that you then have to, is it a requirement for your work that your results can be interpreted, and how do you think about that?
So let me I'll answer the question with regards to the two different things here. One is interpreting the data, and the other is interpreting the predictor. Because interpreting the data is also interesting, right? But maybe I'll answer with interpreting the predictor. And here, my strong view here is that machine learning is sort of opposite to interpretability. That once you decide that you're fine using machine learning, you cannot expect to get interpretability, and you should not require interpretability, because that in particular is going to significantly hinder the machine learning to the point of making it useless. And I distinguish here between interpretability and transparency. So you get transparency. Okay? I can give you all my, so we don't always have transparency. It is important to get transparency. So many of some of the examples we mentioned, we don't even have transparency. And transparency is important. Like, transparency, I mean, I tell you exactly, at the very least, I tell you what my, or basically goes down to tell you what is my predictor. I specify, lay out exactly what my predictor does. I give you, the source code. I give you all the weight settings for everything. Okay? So that makes me transparent, and but it does not make it interpretable. Okay? And it doesn't matter if I'm quantitatively trained or not. Even if I have a model which is made up of a bunch of numbers and a ton of weights, and modern models have tens of millions of weights in them, even if you tell me everything, it's very difficult to say what is it actually doing. In some sense, the whole goal of machine learning is, and think of a face recognizer. People for a long time tried to build face recognizers that were interpretable. Okay? So they looked for eyes, and they looked for noses, and they looked data to train. Where are they going to find the eyes? Where are they going to find the nose? Where are they going to find the relevant object? They use lots of data. There's lots of progress on that, but there's not really a face recognizer. And then the Violin-Jones face recognizer, which was one of the very first big successes of machine learning in computer vision, came out in the early 2000s, I believe. And the Violin-Jones face detector was completely non-interpretable. It did not have any notion of face encoded in, definitely not in the training, and also not in the resulting predictor. It was just some boosted collection of filters that none of them look like faces, but it worked excellent. And I think that is the whole power of machine learning, of stepping away from trying to describe what we want and then we might find an interpretable model and just build a very big system that statistically works. And so even if it's transparent, it's not interpretable. Even if you go to something very similar, you said, I want to know the weights. Okay, so I'll tell you here, just in a very simple linear model, like a logistic regression model, you have a bunch of features, and I tell you, okay, this one I gave a weight of 1.22, and this one I gave a weight of 0.9, and this one 1.03. Then you ask me, well, why did you? So it's relatively, maybe you can say interpretable. At least they can understand what is it doing. It's taking the features and multiplying by some numbers. And you don't need to have a high math degree for that. But why did you choose those numbers? 1.2, and 0.9. And the only answer to that is, well, that's what's supported by the data. But once you get an argument if that's what's supported by the data, then you lose all interpretability, because also my very, very complicated model that I cannot explain to you at all what it does, either the Phelan-Jones-Vince vector, which by modern standards is not complicated, or a big neural net with 10 million parameters, I can perfectly justify it by saying, oh, that's what's supported by the data. It has good error. And that's the only bar for machine learning. And so this is sort of how distinguishing transparency and interpretability, and why I think interpretability, if you really want interpretability, in many cases I think it is important to have interpretability. You should not be using machine learning or data-based processes, but rather more human-based processes.
So who wants to go first?
Yeah,
I know both of you are gonna. So. And I'm sure there are people in the room who want to go as well.
Yes,
People will be around later for
running away.
I have to say that I disagree with almost everything that you said. And this is a hallmark, yes, of a successful panel. So the only thing that I do agree with is what you said towards the end, that sometimes if it is required that things be interpretable, that you should not be using machine learning. So I agree with that sentiment. But I would actually define transparency and interpretability very differently from what you've done. So to me, disclosing, say, the code that implements an algorithm does not help you in any actionable way for multiple reasons. I mean, first of all, a code is a static sort of a thing, right? It needs data on which to operate so that we know what the code computes. And if you disclose just the code but not the data, then you've not disclosed anything. So in New York City right now, there is a bill making rounds that was proposed by a city councilman from the Bronx by the name of Vaca, who wants to require that every city agency that employs data-driven analysis of any kind, doesn't have to be an opaque data-driven learned model, can be just a ranker, let's say, for which we know the scores, that it has to make the code publicly available. And furthermore, an individual, if an individual is impacted by this algorithm, has to be able to submit their particular data to the system and to receive a result, right? Now, the goal of this bill, which has not yet been passed as far as I know, is to provide transparency of city services. And an argument that I would like to make is that it does not in any way make things transparent, because disclosing the code is like showing you the chemical formula of the food that you're about to eat. What does it tell you about its nutritional value, or how well it's going to taste, or how fresh it is? Nothing. Being able to enter your specific data and getting a result back, 42, also tells you nothing. Because say that it's a ranker, and you know that your score is 42. You don't know how well you rank with that score compared to others. How likely am I to receive a spot in, I don't know.
So let me jump in. I don't think Nadi's saying that the code is what makes it transparent. He's saying, I'm going to print out the random forest for you. I'm going to print out the weights of my SVM, or I'll give you whatever the neural network weights are. Even then, you would claim that it's not interpretable.
It's not interpretable because, in fact...
Yeah, we agree.
Yeah. So you agree on a lot of things. Right? I mean, so where...
But I think that interpretability is important, and it's achievable.
I did not say interpretability is not important. I said when interpretability is important, you should not be using machine learning.
I think that's where we
And-
disagree, right?
All right, so that certainly we can talk about some more. So, I mean, basically, the point that I wanted to make is that interpretability is not explaining to people how something works. It's explaining what it does, right? And in fact, it is neither necessary nor sufficient for you to have the code and the data to be able to understand what something does. So if you think about a nutritional label for a food item, it does not give you the chemical composition, but it tells you, you know, the percentage of calories that you get compared to your daily value, and it tells you how much sugar there is. That's all you need to know as a consumer of that particular item.
So you trust the FDA completely.
Yeah.
And if the FDA tells you that this food is good for you today, you don't want to know how they decided that food was good for you, what trials did they run. Not everybody, but would you want the experts, the policymakers to know how did they come up with that? What trials did they run?
For sure, but so what I'm talking about is just the data for a consumer, right?
Right,
I mean,
right.
so trust is a different issue, but suppose that there is an agency that you trust and that gives you information that is relevant to you at the moment and that you can digest, like a nutritional label. Wouldn't you want that for algorithms?
Let me quickly go to Lisa.
I love the food analogy. I love the chemical formula is the code and the food analogy. But I think there's another relevant analogy, and that's is the decreasing price of the genome and genomic counseling. So you guys probably are familiar with spitting in a cup and you can get SNPs, right? But soon we're going to have, it's getting within reach to have your whole genome. The problem with providing people that data is they tend to freak out about these correlations. Does that mean I'm getting cancer? Does that mean this? Does that mean that? And so there's a regulation saying that if you're going to deliver these results, you have to have a certified genomic counselor. And this is a specialty position that did not exist before. Someone who understands psychology and understands that caring, empathy thing, and also understands the science and can explain what it means. And I think that is maybe a better analogy than trusting the FDA, that there needs to be regulation about it, and there needs to be special roles of people who can help with some limited form of interpretability.
So I think you want to respond to that?
Sure, I just made a small comment about this New York City example and the issues of transparency versus interpretability. One thing, transparency, I think we disagree on this than maybe you're saying. But transparency, but what transparency, which is releasing the code or releasing the predictor without actually in a way that I can't even understand it. It's not even a matter of maybe even an expert can understand it. What it does achieve is exactly this issue of trust. Because if if I'm going to tell you the chemical formula of everything in the food, it's not going to tell you anything. It's going to tell me anything. But it means that somebody that is a food engineer, independent food engineer, can take that and can tell me whether that's safe or not. I don't have to trust the food manufacturer to do that. And that's the same. You see that very explicitly with cryptography. If you looked at the, I don't know, maybe you're more of an expert in crypto than I am, but if I looked at the code for some email encryption software, I would not be able to judge whether it's safe or not. But the fact that the code is available makes me trust that it's safe because I know that other people that can understand it and have looked at it, not just superficially look at it immediately, but have studied it, certified in some sense that it's safe, and I trust that much more than the company telling me it's safe. If you buy an encrypted phone that says on it, it's safe, we told you so, what does that tell me? Nothing.
So, I mean, okay, so one of the things that I think interpretability and understanding, one reason why it's at least in my mind critical is a lot of the problems we deal with are not automated decision making in kind of public policy. It's not micro decisions being made automatically by a computer. A lot of these models of these opposite models are being given to a human who has to trust this output. If they don't trust it, they won't act on it. They have to be able to debug it because it could be wrong. The model is not going to be perfect. So if you don't understand it, you might need to understand it to debug it. 3, and most importantly, is this person is taking this output and then figuring out how do I intervene with this. You're saying this person is at risk. Today we don't have enough data and our models aren't good enough to recommend an intervention. They're really mostly risk models. So then we're taking this risk, and if we don't understand why this person is at risk, I can't figure out what to do with it. So given that, in some ways, interpretability in my mind is a core requirement of these systems, and a lot of you kind of agreeing that if you want interpretability, don't use data. That's a little disturbing to me.
Yeah,
So, like, what do you guys?
Sorry, guys. Please finish that question.
But you guys both sort of agree that, yeah, if you don't want.
No, you cannot have just code and without data interpretability.
But a model that's data-driven and based on machine learning, if I wanted that to be a requirement, that model is, hey, you have to be able to explain to me why this prediction was made, because it'll help me figure out how to intervene. Is that something, is that a requirement just not it's not feasible?
So I think it's a complicated, I think it's a very good and complicated question, and there's no easy answer. So I have two possible answers. One is, I think, what is important to understand, to increase the understanding of, is not so much why did the algorithm make the decision it made. That's the part that I feel is hard to get interpretability of. But what does it mean that, what am I actually predicting, and what data is it based on? And especially in these medical applications you mentioned, and in many other predictive systems, you go to policy, and the output system is often misinterpreted. For example, the people have a very hard time understanding calibration of probabilities, to the point that, if you look at the weather, people are going to say 40% chance it's going to rain today. I mean, people have a hard time understanding what that means, to the point that they actually, it's not, if they think it's 40% chance it's going to rain, they actually tell us it's 20% chance or something like that. I mean, they intentionally warp these percentages because they know that people will misunderstand them. And when it gets to, I looked a bit at the criminal justice scores. They do have some correlation, but the correlation is very small. If you actually look at what the actual, how much does an increase in 2 by the score, what does it actually mean? It's very difficult to actually understand that as a probabilistic statement. And that's where I think that is completely orthogonal in my mind from interpretability of why did I score somebody's 3.5. And those type of things I think are possible to achieve by better, both better education of people using the systems about what the systems actually mean, and better design of the system, better integration. And I think that the genomic analogy is an excellent analogy, that it's not enough to just spit out some prediction. You have to sit with somebody that understands humans, understand people, and design a system that presents it in a way that it would not be misused, that helps people understand what that probabilistic prediction means, what is, how much, make some sense of that. So that
But you seem like you're backing off a little bit from the statement, if you want interpretability, don't use machine learning.
No, that's a
Wasn't that statement made?
No, that statement, I still stand by that statement. So what I mean by so if I want to understand why if you want to derive a statistical prediction, and you want to understand why not why, but you understand that what is that statistical prediction, not what is it based off, because I can give you the weights, but why did you why is that the decision to use, or not decision, or why is that a prediction? That is something that if you want that, you cannot. I mean, I'm not saying don't use data, but don't use machine learning.
But you're giving a very specific model class. You're saying if you're building a linear model of some sort, or what if you use a simple nearest neighbor model? How did you pick these weights? Well, these are people. I mean, you could simplify it, so you can use certain classes of machine learning, and you might trade off on performance, and they might not perform as well.
So right. So there's a big trade-off of performance once, but this is a trade-off of performance that, in some sense, goes against, in my mind, the guiding principle of machine learning. So remember, the power of machine learning, the reason it got to very strong success is because it went beyond simple models and into more complicated models. So I'm not saying don't use data, right? So you can have, you can use data, but not so much what I would think of as machine learning.
And you agree?
I disagree that you cannot use machine learning, even the most complex, and I think that it still goes back to what we mean by transparency and interpretability. So to me, it is not an important question to be able to answer why this particular individual, perhaps, got this particular prediction. But what I would like to know is what are the features that matter? What are the value judgments, in other words, that the particular system encodes? So I want to know what is the effect on subpopulations. I want to know what for a particular individual may be, say, a course of action to improve their outcome. But I have trouble imagining a stakeholder who really needs to understand the behavior of the specific model for every data point.
So if I go to get a loan, if I go to get a loan, and you deny my loan, I don't care about the population. I care about my loan. I want you to explain to me why you didn't get my loan.
For sure.
If you're sentencing me and you deny me bail, okay? Not sentencing me, but if you're deciding on a bail and you deny me bail, I want to know why you denied me bail, and you have to explain to me why you denied me bail. I don't care about the population.
Exactly. So I, as an individual, don't care about why the particular decisions were made for everybody else, right? I want to know for my particular neighborhood, for the particular features that are important to me, what was the result, and why were these the features that were used for me? Why was my gender used or not used? Why was my race used or not used? Is this legal?
So you should not be using, so in those type of applications, I'm arguing that it's inappropriate to use machine learning. Because you want
the fact that an
interpretability.
individual cannot comprehend a complex model on an entire data set doesn't mean that they cannot comprehend with a proper explanation an outcome in their particular neighborhood.
So does machine learning belong in the lab, like early small molecule research for drugs before it gets to the FDA and human trials and is prescribed? Should it be isolated from systems that impact society?
Sure, no, it should definitely belong in the lab. Machine learning is used in the lab. It's used, for example, to get candidates. One thing is definitely used for getting candidates for further study. Okay? But when you, a classic pipeline, which is not always followed, right, is that you use machine learning to predict candidates, to make predictions about what could be implicated in some biological process. But at the end, you actually want to understand the process itself. And understanding the process itself is something that you're not going to do necessarily using machine learning. But also, in some cases, even in biology, but more so in chemistry, just having, we use many things without understanding them. I'm not by no means an expert in drug design. I'm by no means an expert in drug design. But there are many drugs, even common drugs that we use, we actually do not understand how they're acting. So we're not actually looking for interpretability here. We're willing to accept drugs purely based on the fact that statistically they tend to work on our population.
We don't need to know how
so that means,
we need to know what they do.
So that means we don't have interpretability. We have no interpretability
My
about this
analogy
drugs.
totally backfired on me. Oh my God, you're right.
I'm going to take a pause. I mean, I don't think we're going to reach, again, this session is not about reaching a conclusion, but, I have a lot of arguments there where I don't disagree, because I don't think machine learning is the narrow thing that I think we are calling it. I think it's a much larger thing. But I want to sort of give some time to the people here to thoughts, questions. Yeah, I'm sure there are. Let's start with, let me give you the mic here.
I'm good.
I know, you all think we don't need a mic, but then nobody can hear us.
Yeah, so this smacks to me of hubris almost. You're telling me that if you trained a random forest on some police model, and every tree split for the first time on race, that you could offer no interpretation in that case. You couldn't say every single tree in the model splits first on race. You say, well, the data says that, I can't offer interpretation. So there's nothing. I mean, that makes no sense to me. You have to be able to interpret that for the people you're giving a model to, and you can't just say, well, I'm the scientist, I don't know, I'm not going to interpret that. But I mean, you can't say that there's no interpretation of machine learning. That's bonkers.
So it's not so. So first of all, I'm not saying that you can never. So obviously, when there's very strong effects, then yes, you can sometimes look at the model and the effect just jumps in your face, like in the case you said. But just to clarify what I mean, when I said I still stand by the fact that you cannot demand interpretability, because you're right, sometimes there's a huge effect that jumps in their face. But even if the first split is not according to race, then just using that and saying, oh, look, I cannot look at the forest, you can't see race anywhere, that does not mean that your system is not racially biased. That's the more dangerous thing. So if you're, in my, what I'm afraid of is by trying to impose interpretability over these models, okay? And when things don't jump in your face, then you're saying, oh look, I looked at it and there's no race anywhere, I can't see race, and so the system is not racially biased. That's the type of failure I'm more concerned about.
So just to add to that, so there's actually beautiful technical work that allows you to study causal effects of attributes, combinations of attributes, on the output of a black box model. So specifically, the paper that I'm in is Quantitative Input Influence, QII, out of CMU. So take a look at that. It is not the case that all is lost. And that there's other work in this direction that, on real data sets has shown that we can interpret results of models for which we don't have the code.
Other questions? We're going to take some questions, but then right after this is the discussion session. So you should just go over there. Is it going to be, does anyone know where it is? Upstairs. Okay, so we're going to have to go down. It would be nice to just do it in this room. Yeah, question. We'll take a few more questions. And then.
So I like the analogy to drug delivery because in clinical research, this is like bias and ethics are something that have been dealt with for a long time. And one of the ways that that community deals with that is to come up with some rules and some guidelines as to what ethical research looks like. What are things you should do and shouldn't do? And that came about after some people did some really shady stuff. So it would be nice if we could maybe start to come up with some ideas of what those principles should be before those bad things happen. And the other thing that clinical research does, so on like animal research and things, is they have, or at least they're supposed to have, a lay community of people who actually comment on the research and say whether this seems good, like a good idea, like is this worth the animal research to justify the outcomes. It's generally not actually lay people, it's like people from the hospital or whatever, but I think those are some like principles that you could start to involve.
Let me just very quickly, so there are two ongoing efforts that you should be aware of. The ACM is revising its Code of Ethics and Professional Conduct, and they ask for feedback from the community in the communications of the ACM. We're now in the 3rd draft. And another related effort is that there is now work starting on a code of ethics for data science. And this was announced at the Data for Good Exchange in New York earlier this week, so do please also look out for those efforts.
I'll take a couple more questions and then we can wrap up. Ben, Ben's been waiting for a while.
I think it's interesting to look at the financial service space. This has been very well litigated in banking. I mean, when I worked in banking, my model, you just, as an input, you just didn't put age, gender, or race. It's just not, because once it's in the system, you can't tease it out. Just like, I think about those nowadays where people take names off of resumes. I mean, once you see the name, you cannot not see it. So people are inherently have all these biases. So if you remove it, you increase the fairness. Second thing is, in the same thing in financial space, people over time have now been legally allowed to see their FICO scores, which they weren't before. And they're allowed to see, you're required by law, if I decline you, I have to tell you what are the 3 attributes that were, if you change. But so I think there's precedent here that we can learn from. It's not perfect, but I think that, I just think there's
I would argue it's a bad precedent, right? Because it's a horrible, I personally think it's a horrible idea to remove those attributes, because then you say, oh, they don't matter. Like, we know that they're correlated with everything else, and we've known that redlining has been an issue. So I think the argument that we have to deal with is people come in and starting with that, where a government agency will say, oh, what if we don't give you these attributes? Because then you're going to be biased unknowingly, and you can't test for the bias because you don't have those. And so you probably end up hurting the people you want to protect more than not doing it. So that's what we've seen in our work is that precedent has essentially hurt us. Because it's just scared the government to do, well, we just remove it. And it also pacifies them by saying, oh, if you remove it, it can't be used.
And this is the fairness through blindness argument, right? That doesn't work. And North Point, the makers of Compass, that software that ProPublica exposed for being racist, their first line of defense is, we do not collect race. We cannot possibly be racist.
I completely agree here. I completely agree there about the removing, that does not achieve anything. And also, I'm not sure if that's also you're saying that, but if you did, I agree also with that. The type of
If I said what you said,
the type of feedback you get for financial, the type of feedback you get about your credit, the three main things, positive and negative, I view them almost. They're not. I think it's a way of kind of hiding away from true transparency and interpretability, because they're not. You train a model that is inherently, I would still argue, uninterpretable there, and then after you train it, you don't actually change it, but you extract from it your best attempt at something, and it's not. It's a bit similar to those food labels where if you have it's like having very extremely coarse food label. If you just tell me in the food label, how many carbohydrates you have and how many calories you have, it doesn't tell me whether if the food is good for me or not, or it doesn't. So it just makes it feel as if I have to.
But this is an issue with the bad implementation of a good idea. It's good precedent that credit reporting agencies tell you something.
It's not a bad. No, I don't think we're arguing.
And it's good
bad.
to have nutritional labels if they're informative.
Yeah, but it's not. It in some sense makes you feel as if you're. It places you without really telling you why you actually.
So it should tell you really why actually.
So I want to take one more last question, and then because Irina has been waiting for a while, do you want to just ask? Hopefully, it's a yes/no question. Do you think you should have ethically?
I'm sorry, it's not even a question. I just wanted to make a comment. So thank you for the great discussion. And Ned, I agree with you. I just wanted to give you my perspective as a practitioner. So I'm working for a startup. We're using a lot of machine learning, and our customers sometimes ask me, like, why does this document have a score of 0.75? And if I tell them the feature, try to interpret, they take it at a face value. So sometimes, like what I hear when you say is like if you have a less sophisticated audience who you try to explain your algorithmic output to you, you should be careful, because they will like literally say, oh, this word, so every document with this word will have a high score. No. It's a very difficult area, so like from a practical perspective. So I think the great discussions otherwise important, but if you're dealing with not data scientists who use the output, then I really much more on that side that it's hard.
No, that's a good point. I want to sort of wrap up because of coordination, but thank you very much for being on the panel. Thanks for all the questions. I'm hoping you guys are all going to go to the next session.